Simplifying and simplifying radicals. Let's first deal with square roots. You need to know which numbers you know the square root of. You know the square root of numbers that are going to end up here. You know the square root of 1 squared. It's 1. You know the square root of 2 squared. That is, you know the square root of 4. It's 2. You know the square root of 3 squared. That is, you know the square root of 9. You know the square root of 16. It's 4. You know the square root of 25. It's 5. You know the square root of 6 squared. You know the square root of 49. You know the square root of 64. You know the square root of 81. You know the square root of 100, etc. You know all the square roots of the numbers in that circle and more. You know the square root of 11 squared. You know the square root of 12 squared, etc. So, if you were asked to simplify the square root of 75, you want to pick the largest number on our list. Our list is what's in there, what I circled. The list of numbers I circled. You want to find the largest number in that list that goes evenly into 75. And the answer is 25. So this is the square root of, so 75 is 25 times 3. So when you have a product underneath the square root sign, and the two numbers that make up the product are not both negative, if they're not both negative, you can take the square roots separately. The square root of 25 is 5, and the square root of 3 you can't simplify. So if you simplify the square root of 75, you get 5 radical 3. You have the square root of 72. I'm going to write it as a product of 2 square roots. Now, I can do 3 and 24. And after all, 3 times 24 is 72. The problem is I don't know square root of 3, and I don't know square root of 24. But though that equal sign is valid, I don't want to use 3 and 24. There's not just any old two numbers that multiply out to 72. I want the largest number on my list that goes into 72. And in this case, it is 36. Goes in 2 times. Square root of 36 is 6. The square root of 2 I don't know. Nor can I simplify it. And there it is. You know, some of you may say, oh, I know this. It's 9 times 8. 9 times 8 is 72. And the square root of 9 is 3. And the square root of 8, well, times the square root of 8. The thing is, we can break down the square root of 8. So here's another way of doing it that we do in 2 steps. The square root of 8, well, 4 is on my list. And it goes into 8. That is 8 is 4 times 2. Square root of 4 is 2. 3 times 2 is 6 times the square root of 2. We got the same answer. It took a little bit more work because we did not find the largest number on the list that goes into 72. Yes, 9 is on our list, and yes, 9 goes into 72. But it wasn't the largest number. It's much, much better if you pick the largest number. Okay, which means that you have to know how to divide. You have to know which of these numbers go into 72. Now, those are the squares, the square roots, what are the squares. What about the cubes? 1 cube is 1. That means I know the cube root of 1. 2 cubed is 8. 2 to the 3 is 8. That means I know the cube root of 8. 3 cubed, 27. the nice thing about this list is since the numbers grow so quickly, you don't have to have as many numbers. 6 cubed is 216. 7 cubed, I guess, is 343. And 8 cubed, I probably don't know. 64 times 8. 64 is 8 times 8 times another 8. 512. 9 cubed, 81 times 9 is, wow, I didn't know I knew so many of these. And of course, 10 cubed is 1,000. Well, I guess I went out to 10 anyways. So we know the cube root of the numbers are circled. For example, the cube root of 125 is 5. The cube root of 512 is 8. But trust me, you probably only have to know it's 5 cubed, which does make the list a bit shorter than the other list. So, if you were asked to simplify the cube root of 24, well, again, we want to write it as one cube root times another cube root. Cube root of one number times the cube root of a second number. And it's not just any numbers like 6 and 4. And 6 and 4 multiply out to 24. I don't know the cube root of 6, nor do I know the cube root of 4. But 8 times 3 is 24. And I know the cube root of 8, it's 2. So it's 2 times the cube root of 3. I'm sorry, but you need to know these lists. You need to know these lists. If you were asked to figure out what the cube root of 54 is, well, 64 doesn't go in, it's too big. But 27 does. 27 times 2. And this is where you have to know how to multiply or divide quickly. I know the cube root of 27. 27, the cube root is 3. I do not know the cube root of 2, nor can I break it down. Now 9 times 6 is 54. But you don't want to mention this cube root of 9 because you don't know it. You don't know the cube root of 6. What about the fourth root of 80? Well, that means we have to know, we have to raise numbers to the fourth power and find the largest number on that list that goes into 80. 2 to the 4th is 16. 3 to the 4th, 3 times 3 times 3 times 3. This is 9 times 9, or 81. And 4 to the 4th will be bigger than 80. Oh, excuse me. That statement is true. But 3 to the 4th is already bigger than 80. So, 16. Yeah. 16 goes into 80. 16 times 5 is 80. 16 times 5 is 80. The fourth root of 16 is 2. So the final answer is 2 times the fourth root of 5. That is your answer. You see, you just need to know these lists. Or you don't have to memorize them if you don't want, but you need to be able to list them. I mean, I do not remember this list. 4, 9, 16, 25, 36, 49, 64. I don't remember it. How did I just write it down so quickly? I asked myself, 2 squared, 3 squared, 4 squared, 5 squared. I asked myself what 6 squared was. And I can do that quickly. That's 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared. You need to know your times table. And then you put the list down quickly. So there's really no need to remember 4, 9, 16, 25. That's silly. You have better things to do with your time. You should just know 2 squared is 4, 3 squared is 9, 4 times 4 is 16, 5 times 5 is 25, etc. Now, that's what happens when you have numbers. When you have letters, it's much, much easier. If somebody were to ask you what's the cube root of a to the 6th, b to the 7, c to the 11s, d to the 4, and let's even have the denominator. Cube root over e to the 5th, f to the 2nd. Well, what you're going to get is those same letters in the same location, top or bottom, times the cube root of those same exact letters, and all that needs to be filled in are the exponents. For A, you do 3 into 6. It's just a few division problems. 2, 0. You put the 2 there and the 0 there. It's just long division. 3 into 7. And the numbers aren't ever really big, like 29 into 3,211. They're usually, small numbers. 3 into 7. Those 2 times remainder 1. There's the 2, there's the remainder 1. For the C, you just do 3 into 11. Those 3 times, I used up 9, 2 left over. Okay, 3 and 2. 3 into 4. Goes 1 time, with 1 left over. 1, 1. And now you do 3 into 5. It's just long division. Let me put it down here. 3 into 5. Goes 1 time, remainder 2. 1, 2. As easy as 1, 2. And then you do the same thing for F. You do 3 into 7. You do 3 into 7, and coincidentally, we just have that one. Goes 2 times, remainder 1. Now, let's simplify this. Let's clean it up a little bit. If the power is 1, you don't need it. You don't need to write the 1. For example, b to the 1 and e to the 1 are just b and e. If the power is 0, you don't have to write anything. For example, a to the 0 is 1. You don't need to put the 1. So, if a squared, b squared, c cubed, b to the 1 is just b, e to the 1 is e, times f squared, times the cube root, a to the 0 you don't have to write, b to the 1 is just b, c squared, b to the 1 is b, so let me not write the 1, e to the 2nd is e to the 2nd, and f to the 1 is just f. And there it is. It's just long division and then cleaning up a little bit. If the exponent is 1, put the base, don't put the exponent. If the power is 0, then it's 1. You don't have to write it. There's one exception. If you have the square root of a to the 0, b to the 0, over c cubed d to the 4th, you have to put something on top. And I'm kind of saying, if the powers are 0, put nothing. Ignore it. But if you only have a to the 0 as well, and times b to the 0, you have to put the 1. And in the bottom, you would put the c cubed d to the 4th. Okay, other than that, if the exponent is 0, don't put anything. But then if in the end you have nothing in the numerator, why? Because all the exponents were 0, well then put the 1. Okay, let me really hammer that in. If you have a to the 0 b cubed, I am saying that a to the 0 is 1 times b cubed. But 1 times b cubed is just b cubed. And if you had c to the 4th as well, 1 times b cubed times c to the 4th is b cubed c to the 4th. That is, you can just have really ignored the a to the 0. But if there was only power 0, a to the 0, b to the 0, you just can't put that and say, here's my answer, square root. My first question would be square root of what? This can't have a square root. What if you have -4, the cube root of 54, x, y to the 5th, just that? Well, what you should realize, it's -4 times this. It's -4 times that. Let's put all our energy into figuring out what that is. What I might suggest is, since they're done completely differently, the letters and the numbers, why don't we just isolate them or separate them? The cube root of 54. Well, 2 cubed is 8. 8. And 3 cubed is 27. And 4 cubed is too much. It's 64. 27 goes into 54. It's 27 times 2 times the rest. Let's not forget the rest. Okay, the cube root of 27 is 3. The cube root of 2 we don't know. Now, for this piece here, we play the game we've been playing. You have x and y in front of the radical sign, and you have x and y underneath the cube root sign. Then you do division. Remember, it's x to the 1. 3 into 1 goes 0 times, remainder 1. So 0, remainder 1. Then you do 3 into 5. 3 into 5 goes 1 time, remainder 2. 1 time, remainder 2. First thing I'll say is we don't need the x to the 0. Now, what's not under the radical sign from the whole thing? You have 3 times y to the 1, which is just y. Y to the 1 is y. 3 times y is 3y. What's underneath the cube root sign? 2 times x to the 1, which is x. So it's 2 times x times y squared. 2 times x times y squared. And there's the answer. The numbers were much harder. The letters are simple. It's just long division. But you have to know that x to the 0 is 1 and x to the 1 is x. Now, what if you're given a problem like this? The square root of 50 times the square root of 2. Now, sometimes, not always, sometimes it pays to multiply the 2 together. Other times, it pays not to multiply the 2 together, which is not good. It'd be good if there was always one answer. In this case, since 50 times 2 is such a friendly number, 100, friendly because we know the square root of 100, it's very, very friendly to multiply the 2, to write it as one radical. Likewise, if you have the cube root of 2 times the cube root of 4, they're both cube roots, so you can multiply what's underneath them. 2 times 4 is 8. What times itself 3 times gives you 8? 2. 2 times 2 is 4 times 2 is 8. the 50 and this 3, you get 150. But you don't know the square root of 150, and the numbers got bigger. What you can realize is that the largest number that you know the square root of that goes into 50 is 25. That is, it's the square root of 25 times the square root of 2. That's the square root of 50. Please don't forget that you're multiplying that by the square root of 3. The square root of 25 is 5. The square root of 2 you don't know. The square root of 3 you don't know. See? Let's write it down as one radical. That is, multiply 2 and 3 and get 6. So right now, that's what we have, 5 square root of 6. And you should ask yourself, let me just write that here. You should ask yourself, can you break down the square root of 6? The answer is no. You don't know the square root of any number that goes into 6, other than 1. Okay, so there it is. Now, if you did say that's the square root of 150, the thing is, you're going to get back to where you started. 50 times 3 is 150. You're going to get back to where you started. That is, you're going to get right back to like that. The largest number that goes into 150 that we know the square root of is 25. And it goes in 6 times. This is 5. This is square root of 6. 5 square root of 6. Of course, we got the same answer. But we dealt with bigger numbers. We paid a price up here. We actually had to multiply 2 times 3 to get 6. Here, the 6 came for free. The only thing is, you had to know what's the largest number that you know the square root of that went into 150. Way, way bigger than 50. Sometimes you really don't want to do it. Now, let's go back and do the top one again. I told you that sometimes you can multiply them. Actually, every time you can multiply them, and every time you can simplify without multiplying. So one is easier than the other. Now, if I chose not to multiply the 50 and the 2, I ask myself, what's the largest number that I know the square root of that goes into 50? The answer is our 25 times 2. This here is the square root of 50, or equal to the square root of 50, times the square root of 2. Well, square root of 25 is 5, and square root of 2 times the square root of 2 is 2. The square root of any number times the square root of that same number is equal to the number. This is only if the number is not negative. If the number is negative, that's a whole nother story. Okay, so it's 5 times 2, or 10, just like we got above. An alternate way could have been the square root of 25 stays. 2 times 2 is 4. The square root of 25 is 5, times the square root of 4 is 2. And 5 times 2 is 10. Now, I do want to point out something. I don't usually like to grade or talk about mistakes that students make. But this mistake I'll talk about. I hear students all the time say, the square root of 16 is 4. But they don't write down 4. This is not 4. That's the square root of 4. If you think the square root of 16 is 4, whether you're right or wrong, I mean, that's your best guess. The square root of 16 is 4. Well then, it'd be suicidal to put down 7. I mean, okay. It'd be suicidal to put down negative 8. If you think the answer is 4, you shouldn't put down 2/3. If you think the answer is 4, you shouldn't put this down, because that's not 4. That's not 4. It's not 4. The square root of 16 equals 4. If you think that 7 plus 3 is 11, right or wrong, you wouldn't write 27. you'd write 11. If you think 7 plus 3 is 11, that's what you're right. You'd be wrong. You'd be wrong. But if you think it's 11, put 11. Be suicidal to put anything but 11 if that's what you think the answer is. And the other thing is, if you think the square root of 16 is this, well then why don't you simplify this? It amazes me how many students would then write 2. I mean, why not write square root of 2? And none of those equal signs are correct. You think the answer is whatever you think it is, don't write down a different number. That's suicidal. Just giving it away. Suppose you have the cube root of 2x squared y squared. Well, let's make this a 4. So you should figure out, you should square first. You should square first. 4 squared is 16. X squared squared. That means you multiply the exponents. X squared squared. Addition, multiplication, exponents. Since you have exponents, you go down to multiplying. So in this case, even if you added, it would have been the wrong technique. But in this case, it doesn't matter because 2 times 2 is the same as 2 plus 2. And there's an understood 1 here, multiply it by 2, get 2. Now you say, oh shucks, there's a number there. You need to simplify the square, the cube root of 16, but the rest is just long division. The cube root of 16. Well, 2 cubed is 8. You know the cube root of 8, and 8 times 2 is 16. And now you have the rest. The cube root of 8 is 2. The cube root of 2 you can't simplify. Now the letters. xy under the cube root sign. You do long division. 3 into 4 goes 1 time with 1 left over. 3 into 2, it goes 0 times with 2 left over. So the final answer will be 2 times x times 1, which is 2x, times the cube root of 2 times x times y squared. 2x y squared. And there's the answer. Here it is. Suppose you were asked to simplify the following. Two times 2 square root of 8 minus 3 square root of 2. Square root of 8, the largest number, another square root of that goes into 8 is 4 times 2. I know this is the square root of 4, this is the square root of 2. So this becomes 2 times, let me stop, 2 times the square root of 8, which is 2 square root of 2, minus 3 square root of 2. This is 4 square root of 2's. And you take away 3 square root of 2's. You have 4 of anything. And you take away 3 of them, you have 1 left. You have 1 square root of 2. You want to put the 1 down in front? Put the 1 down. Nonetheless, 2 times square root of 2 is 2 square root of 2, or if you prefer, 2 times 1 is 2, times square root of 2 is 2 square root of 2. Suppose you have the square root of 5 times the square root of 5 plus the square root of 3. Final answers should have the fewest number of radical signs as possible. Right now there are 3 of them. If I can write it down with less than 3, then you need to continue. Then you can simplify. The square root of 5 times the square root of 5 is 5. Plus, the square root of 5 times the square root of 3 is the square root of 5 times 3, which is 15. Now, here's 2 squared and 3 squared and 4 squared and 5 squared. Okay, don't go 16 and 25 are too much. Neither of those numbers go into 15, which is good, because that means I can't simplify any further. And I know that I made progress because on the top, I had 3 radical signs, and now I have 1. That's an improvement. So I did simplify. And here's a nice one. Square root of 2 times the square root of 8 plus the square root of 18. You multiply, they're both radicals, so you can multiply the numbers under the radicals. 2 times 8 is 16, plus square root of one number times the square root of another number is the square root of the product of the two numbers. 2 times 18, 36. How nice. I know the square root of 4. I know the square root of 6. That's just 10. That top line is just a complicated way of writing 10. Now, I don't expect you to walk around the streets knowing that this is 10. But we just worked it out. We just worked it out. It's 10. So for the next minute or two, we know it is. So somebody, if the next problem is that says to simplify this, I hope you realize it's just 22. Because complicated or not, that's 10. We just worked it out. 10 plus 12. This equals 10 plus 12. 22. Now, 5 minutes from now, I wouldn't expect you or myself to remember that that's 10. But now we know it is. For the next minute or two. Okay, how about the fifth root? The fifth root of 16 xy x to the 7, y to the 6. We're going to multiply that by the fifth root of 2x to the 6, y to the 9th. 2x to the 6, y to the 9th. Like I said, the fifth root minus the fifth root of 10x cubed y to the 7th. Okay, suppose you have this problem. I need this for you. The fifth root times the fifth root. The fifth root of one thing, whether it's complicated, the nth root, I don't care what n is. In our case, n is 5. The nth root of one thing times the nth root of another thing is the nth root of their product. And a can be 16x to the 7, y to the 6. It can be anything. But you still get the fifth root. Okay, 16 times 2, 32. X to the 7th times x to the 6th is x to the 13th. Add the powers of y, you get 15. Minus, it says minus. And do the same thing here. 16 times 10, 160. X to the 7th times x cubed is x to the 10. 6 plus 7 is 13. Okay. So let's simplify each one. The fifth root of 32. The fifth root of 32 is actually 2. 2 times 2, 5 times. 2, 4, 8, 16, 32. Now, x and y. Well, xy, xy. Some goes underneath the fifth root sign, some does not. Okay, 5 into 13 goes 2 times, that's 10, 3 left over. 5 into 15 goes 3 times with nothing left over. Minus the fifth root of 160. Well, 2 to the fifth is 32. And 3 to the fifth, 3 times 3 times 3 times 3. That's 9 times 9. That's 81 times another 3 is 243. That's bigger than 160. If you know what 160 is 32 times 5. So the fifth root of 160 is the fifth root of 32 times the fifth root of 5. But I know the fifth root of 32. It's 2 times the fifth root of 5. So I have 2. I have the fifth root of 5. And then you have x and y's. X and y's. 5 goes into 10 2 times. There's nothing left over. 5 goes into 13 2 times with 3 left over. Okay, now we are going to clean this up. We have 2x squared y cubed times the fifth root of x cubed times y to the 0, which is 1, minus 2x squared y squared, the fifth root of 5, x to the 0 is 1, 5 times 1 is 5, times y cubed. Okay, now let's factor. Between here and here, they both have the 2. They both have 2 factors of x. And between y cubed and y squared is common. And there's nothing common under the radical sign. You have x cubed in one, under one radical, and 5y cubed in the other. Nothing's common. Okay, so what does this get multiplied by to get this? Well, you need that third y. And you have the fifth root of x cubed. Minus, I pulled out the 2. I pulled out the x squared in front. I pulled out the y squared in front. But this radical was not in front. So there's the answer. Yes, Well, at the beginning we had 3 radical signs and I got it down to 2. But nonetheless, even if the problem started with the second line, I still simplified because I was able to factor out stuff. I still ended up with 2 radical signs, but I factored out stuff. And if you look under the radical signs in the last line, they're a lot cleaner looking than what's in the second line. But nonetheless, that's your final answer. Okay, and that completes this section on multiplying and simplifying radicals.